So what we did here, integrating factor f equals to 1 by mx minus ny, m is equals to, here it is
After
x
x
square y
equals
cube
y
plus
cube,
2y multiplied with x, and n is equals to 2x minus
2x
of 2xy multiplied with y, and minus we have here. So we have here, then we'll get integrating factor is 1 by 3x cube y cube. So this is after finding integrating factor, what we have to do, multiply the given equation number 1 with this integrating factor, then we'll get equation number 2. That equation we have to compare with m1 dx plus n1 dy equals to 0. Then we can identify m1 and n1. From m1 and n1, find out dou m1 by dou y and dou n1 by dou x. And if both are equal, then we can say equation 2 is exact. For that exact differential equation, we have to find the solution. So with this, I'm stopping this type. Now going to explaining type 3. Now I'll explain type 3 and type 4 at a time. Type 3 and type 4 at a time. So type 3, first of all, type 3. So type 3 and 4 both are at a time, but whenever it requires, then I'll separate it. What is a type 3 and what is a type 4? So now, as usual, we have to check if mdx plus ndy, mdx plus ndy is equals to 0, is a non-exact dA, is a non-exact dA as usual. Then whenever it is non-exact, what we have to check? We have to check immediately, it is a homogeneous or not. So we identified that if it is homogeneous, which type we have to use? Type 1. If it is non-homogeneous, sorry, don't mention non-homogeneous, it is not a homogeneous DE, then we have to go for type 2. Okay, if it is not a homogeneous DE, then we have to go for type 2. What is the type 2? It is y into f of xy into dx, y into f of xy into dx, dx coefficient must and should be y, plus x into
g of
xy.
xy
Don't
into
mention
dy.
commas in between x and y, into dy equals to 0. It should be in this form. If it is in this form, then integrating factor is 1 by mx minus ny. But now we are discussing about type 3. If we want to discuss in type 3, then we have to mention it is not in the form of, yes or no? It should not be in this form. And then we have to check one more point. One more point we have to check. The one more point is here, we have to check, we are finding dou m by dou y and dou n by dou x. Okay, so taking the difference of dou m by dou y and dou n by dou x, dou m by dou y minus dou n by dou x. I'm taking the difference of this. After taking the difference, if I'm dividing it with otherwise multiplying with 1 by n, 1 by n, 1 by n, then it must and should be only in functions of x, only in functions of x, functions of x or constant, or constant. I can take it is only in functions of x or constant. Then we are going to take it is as f of x, say like this. Then integrating factor I of equals to, then integrating factor I of equals to e power integral this whatever we have taken f of x into dx. This is IF formula. This is IF formula. So here now I'm going to take a next type, type 4. Type 4. What is the type 4 is? Here also the same conditions what we discussed here. Like okay, I'm mentioning all these things here also. mdx plus ndy is not a exact differential equation, and it is not a homogeneous differential equation, and it is not in the form of y into f of xy into dx plus x into g of xy into dx. Here also we have to take same conditions we have to take here. So all these conditions satisfies in type 4 also. Okay, all these conditions satisfies in addition to this. So what we are finding here, dou m by dou y minus dou n by dou x. I am finding here also the same, dou m by dou y minus dou n by dou x. If I am multiplying this with minus 1 by m, you have to remember it, whenever you are taking m, you have to treat it as minus 1 by m. It mustn't should be only in functions of y variables. So what is that? Only in functions of y or constant. It may be only in functions of variable or constant. Then we have to take the integrating factor I of equals to. Then how to take integrating factor I of equals to e power integral g of y into dy. E power integral g of y into dy. And how to remember 1 by n, when we take 1 by n functions of x, when we take minus 1 by m, it will be in functions of y variable. How to remember that? For that I am going to give you a logic here. So the logic is here, I am taking shading. So when we multiply with 1 by n, so n is the coefficient of which variable? dy. So y should not exist in that function. Y should not exist in that function. That means it is only in functions of x variable or a constant variable. So 1 by n. Whenever I am taking the type 4, we are taking minus 1 by m. M is a coefficient of dx. M is a coefficient of dx. So it should not be minus 1 by m into dou n by dou m minus dou n by dou x. Should not be in functions of x. So I'm taking it is only in functions of y variables. Only in functions of y variables. This is very important. Okay, once if you understood it belongs to type 1 or type 2, then easily you can identify the integrating factor. And I'll tell you, while we are discussing the problem, we have to take 1 by n or minus 1 by m. 1 by n తో చేయాలా మైనస్ 1 by m తో చేయాలా అనేది ఎట్లాగా ఐడెంటిఫై చేయాలనేది నేను ప్రాబ్లం అప్పుడు చెప్తాను. సో ఈ రెండు ప్రాబ్లమ్స్ కి కలిపి ఒక ప్రాబ్లం డిస్కస్ చేస్తాను. ప్రాబ్లం మొత్తం డిస్కస్ చేస్తాను. సో బెటర్ ఐఎమ్ టేకింగ్ ఏ ప్రాబ్లం నౌ regarding. Okay, now we have to find the solution of we have to solve this differential equation xy cube plus y into dx plus 2 into x square y square plus x into plus x plus y power 4 into dy is equals to 0. This one, for finding its solution, we have to compare with m dx plus n dy equals to 0. M dx plus n dy is equals to 0, and take it as equation number 1. So first we have to check whether it is exact or non-exact. So that I am finding m equals to xy cube plus y, and n is equals to 2 into 2 kuda తీసుకోవాలి, 2 into x square y square plus x plus y power 4. Okay, so finding dou m by dou y, dou m by dou y. So if we do partial differentiation with respect to y, treat x constant. So x constant avutundi. Differentiation of y cube is 3y square, so it will become 3xy square plus differentiation of y is 1, and dou n by dou x, dou n by dou x. When we find dou n by dou x, 2 is constant. Partial differentiation of n with respect to x, treat y constant. So we'll get y square as it is vachestundi. Differentiation of x square is 2x plus differentiation of x is 1 plus y power 4, differentiation is 0 because y is a constant. Doing partial differentiation with respect to x, treating y as constant. అందువల్ల 0 అయిపోతుంది. సో ఫైనల్గా ఏమవుతుంది మనకి ఇక్కడ దిస్ విల్ కమ్ యాజ్ 4x y square plus 2. Check whether these two values are same. No, not equal. Then we can say therefore dou m by dou y
not equal to
is not equals to dou n
dou
by
n by dou x.
Hence equation 1 is non-exact. Given differential equation 1 is non-exact. If it is non-exact, then we have to convert it into exact. For converting it into exact, we have to use a integrating factor, a function phi of x comma y in the definition I mentioned. So that integrating factor we need to find. For finding that integrating factor, first we have to check whether it is a homogeneous differential equation or not. Check what is the sum, how many number of terms are there for dx? 2 terms. What is the sum of powers of x and y in the first term? It is
1.
X power is 1, y power is 3. Add sum of x and y powers 4. So what is the second term? Simply y. Nothing but
y.
0, y power 1. So what is the sum of powers of x and y? 1. So first one, no. So we can say clearly it is not a homogeneous DE. I am going to mention clearly equation 1 is not a homogeneous DE. Non-exact differential equation, hence equation 1 is a non-exact DE, and it is not a homogeneous DE. If it is not a homogeneous, then we have to check whether it is in the form of type 2 or not. What is the general form of type 2? Y into f of xy, y f of xy into dx. Y అనేది ఎట్లా గుర్తుంచుకోవాలి? dx కోఎఫిషియంట్ y ఉండాలి కంపల్సరీ, ప్లస్ dy వస్తుంది ఇక్కడ, dy కోఎఫిషియంట్ x ఉండాలి, x into function xy not x comma y equals to 0. ఈ ఫామ్ లో ఉందో లేదో చూద్దాము. సో ఇచ్చిన డిఫరెన్షియల్ ఈక్వేషన్ లో మనము dx కోఎఫిషియంట్ లో నుంచి y కామన్ తీయచ్చా? y కామన్ తీస్తే ఏమొస్తుంది చెప్పు? y into x y square plus 1 into dx. ఓకే, ఫర్గెట్ అబౌట్ రెస్ట్ ఆఫ్ ద థింగ్. ఇక్కడే మనకి క్లారిటీ వచ్చేస్తుంది. ఇక్కడ మనము xy ప్లేస్ లో z పెట్టచ్చా? పెట్టచ్చు. కానీ z ఇంటూ y గా మిగులుతుంది. y ఎక్సెస్ ఉంది కదా, x పవర్ 1 y పవర్ 2. x పవర్ ఎంత ఉంటే ఒక టర్మ్ లో y పవర్ కూడా అంతే ఉండాలి. అప్పుడు మాత్రమే మనకి ఫంక్షన్ ఓన్లీ ఇన్ టర్మ్స్ ఆఫ్ xy లలోకి వస్తుంది, లేకపోతే రాదు. సో ఇది ఆ ఫామ్ లోకి రాదు కాబట్టి దెన్ ఐఎమ్ గోయింగ్ టు మెన్షన్ దిస్ ఇస్ యాస్ అండ్ ఏమని మెన్షన్ చేస్తాము? అండ్ it is not in the form of, it is not in the form of, in the form of y into f of xy into dx plus x into g of xy into dy equals to 0. ఈ ఫామ్ లోకి ఉండట్లేదని చెప్పేసాం. ఈ ఫామ్ లో కూడా లేదు కాబట్టి ఏమవుతుంది? టైప్ 2 కూడా ఎగ్జిస్ట్ అవ్వదు, టైప్ 3 కానీ టైప్ 4 కానీ. సో 3 కండిషన్స్ సాటిస్ఫైయింగ్. వాట్ ఈస్ దట్? నాన్ ఎగ్జాక్ట్, not a homogeneous, not in the form of type 2. Then we have to check whether it is we have to find dou m by dou y minus dou n by dou x. So going to find dou m by dou y minus dou n by dou x. First to find out this, don't go for 1 by n into something or minus 1 by m into dou m by dou y minus dou n by dou x. First to find out dou m by dou y and dou n by dou x, the subtraction of these two. So what is dou m by dou y? We got in the previous steps, we got dou m by dou y is equals to 3xy square plus 1 minus of dou n by dou x. What is the dou n by dou x? We got
4xy square
plus 2. ఇక్కడ రెండింటిని సబ్ట్రాక్ట్ చేస్తున్నా కాబట్టి బ్రాకెట్ కంపల్సరీ పెట్టాలి, బ్రాకెట్ కంపల్సరీ పెట్టాలి. ఓకే, సరే. ఈ వచ్చే వాల్యూకి మనం ప్రీవియస్ ఒక వాల్యూతో కంపేర్ చేయాలి, ఏంటో చూద్దాం. సో 4 times of xy square sorry, 3 times of xy square minus 4 times of xy square. Then we'll get minus xy square plus 1 minus 2, nothing but minus 1. So this is just dou m by dou y minus dou n by dou x. This is just dou m by dou y minus dou n by dou x. Okay, so I'm putting in box just for our convenience, for comparing with something else. I'm taking here it is as a box. Now I'm going to write m and n values. What is m and what is n from the given problem? So m is equals to xy cube plus y, n is equals to 2 into something. So xy cube plus y is m x y cube plus y, and n is equals to 2 into x square y square plus x in plus y.
Y power.
So x square plus y square, sorry, x square y square plus x plus y power 4. So this one. Now, I mentioned while we discussed procedure, we have to multiply dou m by dou y minus dou n by dou x with 1 by n or minus 1 by m. Which one we have to consider? That is important point here. For that purpose, I have written here m and n functions here. Now, if you observe how many number of terms are there in dou m by dou y and dou n by dou x minus dou n by dou x. How many terms are there here? Dou m by dou y minus dou n by dou x. How many terms are there? There are 2 terms, minus xy square minus 1. I am unable to hear your voice. You are muted. Okay. Now, here, dou m by dou y minus dou n by dou x contains 2 terms, minus xy square minus 1. But when it comes to m also contains 2 terms. But what about n? N contains how many number of terms? 3 terms. 3 terms are there. Now, if I am dividing these 2 terms with the 2 terms function, then there may be a chance it may get cancelled, or 2 terms తో ఉన్నదాంతో డివైడ్ చేస్తే ఈ 2 terms క్యాన్సిల్ అయ్యే ఛాన్స్ ఉంటుందా, లేకపోతే 3 terms ఉన్నదాంతో క్యాన్సిల్ చేస్తే 2 terms క్యాన్సిల్ అవుతుందా? 3 terms ఉన్నదాంతో 2 terms ఉన్నదాన్ని క్యాన్సిల్ చేయలేము. So we cannot cancel the 2 terms function with the 3 terms function. So we cannot take n. So there may be a chance of m only. So that I'm writing here multiplying with the minus 1 by m. So what is according to our procedure, minus 1 by m into, are you able to hear, dou m by dou y minus dou n by dou x. Then what is minus 1 by m I am taking? What is m? X y cube plus y is the denominator m. And the numerator dou m by dou minus dou n by dou x is minus xy square minus 1. Now I am multiplying the above 2 terms, that means the numerator part 2 terms with minus 1, then it will become xy square plus 1. And from the denominator I am taking y common. 1 second. If
Y
you take a y
into
common, xy square plus 1 will get. So if we observe xy square plus 1, xy square plus 1 gets cancelled, the final value will be 1 by y. So as we discussed in the type 4, minus 1 by m into dou m by dou minus dou n by dou x must be only in functions of y variable. It should not have any x variable. So taking here also we got only y variable, 1 by y only. So taking it is as g of y. So say, for example, in any case, if we are getting this value contains x variable, then we are not supposed to take this. 99.99% will not get like that. So minus 1 by m into dou m by dou minus dou n by dou x, if we take, then we'll get only in functions of y variables. Then according to our procedure, IF. Integrating factor is e power integral of y into dy. Dy is equals to e power integral 1 by y into
1 by
y. What is the integration of integration of 1 by y? Is nothing but
e,
log y.
e power log by.
Exponential and log gets cancelled, we'll get only y, which is integrating factor. So now we got the integrating factor. With this integrating factor, we have to multiply our mdx plus ndy equals to 0. This differential equation we have to multiply with this integrating factor. So multiplying equation 1 with multiply equation 1 with
Yes,
if, integrating factor on both sides. Then we will get, so x y cube plus y is m x y cube plus y into if is y
by
into dx plus 2 into
2 into
x
square
square y
square
square plus x plus y power
plus y
4
power
is n, multiplying this with y because if into dy equals to 0. So comparing this with taking this as equation number 2. Okay, anyhow we have to multiply it, but instead of wasting our time, so I'm taking like this. So compare with m1 dx plus n1 dy. Compare with
1 day.
m1 dx plus n1 dy. n1 dy equals to 0. Now here m1 equals to, multiply these two factors with okay, these two terms with y, then we'll get x y
X
power 4
y power 4
plus y
plus
square,
square.
and n is equals to 2x square. Multiply these two terms with the 2y, three terms with the 2y. So 2x square y cube plus 2xy
2
plus 2 into y power 5. So this is n. Now, sorry, this is n1. This is n1. Now, we have to find out dou m1 by dou y. While finding dou m1 by dou y, we have to treat x as constant. X is constant. Differentiation of y power 4 is 4 into y cube plus differentiation of y square is 2y. Now, dou n1 by dou x. Dou n1 by dou x. So 2 into differentiation of 2x square y cube. Partial differentiation of n1 with respect to x, treat y constant. 2y cube into differentiation of x square is 2x plus 2y is constant. Differentiation of x is 1 plus 2y power 4. Differentiation with respect to x partially is 0. So finally we'll get 4xy cube plus 2y.
2y.
So this is dou m1 by dou y, and this is dou n1 by dou x. Check, both the values are same. 4xy cube plus 2y. Therefore, we can say that. Therefore,
Dou m1
dou m1 by dou y is
equal
equals
to
to
dou n1.
dou n1 by dou x. Hence, equation 2 is
Exact.
equation 2 is an exact DA.
Exact differential.
An exact DA. Then, if it is exact DA, then we need to find its solution. What is the general solution? Then its
Integral
general solution is
1 dx.
So the formula is integration of
Integral m1 dx.
integration of integration of
Is
m1 into
m1
dx
dx y
y
constant
constant
plus integration
plus integration of
terms
terms
which do not
which
Do not contain X in N1.
which do not contain
X in N1 into dy.
x in n1
N1
into
into dy.
dy equals to
Equal to
integration of
integration.
0. So this is the thing. Now integration of m1 is equals to, this is m1, x y
X
power 4 plus y square, x y power 4 plus y square. I mentioned here m1 and n1. So anyhow, I'll mention again with the red color boxes. This is m1 and this is n1. So m1 is xy power 4 plus y square, x y power 4 plus y square into dx. We have to treat this is y as
by
constant, plus the terms which do not contain x in n1. So here n1 contains 3 terms. So the first term contains x variable, yes, so we cannot take this term. The second term also contains x variable, so we cannot take this term also. And the third term does not contain x variable, so we can take only one term. That one term is 2y power 5. 2y power 5 we have to take. So we get
into dy.
here 2y power 5 into dy is equals to integration of 0. So while we are doing integration with respect to x variable, and also on the first integration, we have to treat y as constant here. So treating y as constant, y power 4 is constant. Integral x into dx is x square by 2 plus y square into integration of 1 into dx. Integration of 1 into dx is nothing but x plus 2 is constant, bringing outside of integration. Integration of y power 5 with respect to y, integration of y power 5 with respect to y is equals to y power 6 by 6. So total integration completed. I'm taking c on the right hand side. So any simplification we'll do here. So 1 by 2 into x square y power 4 plus x y square plus 1 by 3 into y power 6 is equals to c. This is our general solution of is required general solution of equation 2 as well as given non-exact DE. ఇచ్చిన నాన్ ఎగ్జాక్ట్ డిఏ యొక్క సొల్యూషన్ అవుతుంది. సేమ్ మేనర్ it is a solution of exact DE equation number 2. Okay, so this is our solution. Okay, so till now we discussed one problem on type 1, type 2 and type 4. I didn't discuss any problem on type 3, but for the name's sake I'm taking a problem and I'll just explain up to finding integrating factor, and that too simple steps ga cheppestaను. So taking it is as what is the general form of
mdx plus ndy.
mdx plus ndy. Now tell me, what is m here?
2xy.
Check it clearly. Check it clearly.
X square plus y square
Minus of x square plus y square plus 1. That is m. So in till now we discussed all the problems. mdx plus ndy is equals to 0 form. In general, the first term will be dx only, but here they given first term is dy. So be careful. We have to identify dx coefficient only. We have to take as m. So here dx coefficient is a minus of x square plus y square plus 1. So I am writing it is as minus x square minus y square minus 1. This is m, and n is equals to dy coefficient. Dy coefficient is 2xy. Dy coefficient is 2xy. So finding dou m by dou y. Dou m by dou y is equals to partial differentiation of m with respect to y, treat x constant. So first term value is 0 minus 2y minus 0. So we are getting this value is minus 2y. And dou n by dou x. Partial differentiation of n with respect to x, treat y constant. Treating y constant. So 2y into differentiation of x is 1. So these two values are both are same? No. Therefore, dou m by dou y is not equals to dou n by dou x. Therefore, given equation number 1 is non-exact. So taking this as equation number 1. Therefore, hence, given dE is a non-exact dE. Non-exact dE. So whenever it is non-exact, we have to check whether it is homogeneous or not. Now, check what is the condition for checking homogeneous or not. In the first term, dy coefficient contains x power 1, y power 1. Only one term is there. So what is the sum of powers of x and y? It is 2. It is 2. But when it comes to the second term, dx coefficient, x square plus y square plus 1, 3 terms are there. In the first term, what is the sum of powers of x and y? X power is 2, y power is 0. So sum of powers of x and y is 2. And ఇక్కడ వచ్చింది 2నే. ఇక్కడ second term తీసుకుందాం రైట్ సైడ్ లో. సారీ సెకండ్ టర్మ్ లో సెకండ్ టర్మ్. సో x power is 0, y power is 2. Sum of powers of x and y is also 2. ఇక్కడ 2నే ఉంది. సో అన్ని ఒకేలా ఉన్నట్ట. ఇక్కడ చూద్దాం ఇంకొక టర్మ్ మిగిలిపోయింది. What is the thing we have here? It is only one. Nothing but we have x power is 0, y power is 0. Sum of powers of x and y is 0. So ఒక టర్మ్ లో 2 ఉంది, ఇంకొక టర్మ్ లో కూడా 2నే ఉంది, ఇంకొక టర్మ్ లో కూడా 2నే ఉంది, ఇంకొక టర్మ్ 0 ఉంది. Sum of powers of x and y. So we can say that this differential equation is not a homogeneous. Not a homogeneous. Homogeneous కాదు. Homogeneous కాదు. Not a homogeneous. Okay. So and it is not a homogeneous dA. Then we have to check about we have to take check about whether it is in the form of type 2 or not. While we are we have to check with the type 2 or not. The coefficient of dy must have can be taken x common. So we can take x common. If we take x common, then what we'll get? X into 2y only. This remaining part must be in functions of xy, x into y, but it is only in functions of y variable. So it is not in the form of and not in the form of. I'm mentioning simply type 2. Type 2. ఆ టైప్ 2 ఏంటి అనేది మనకు తెలుసు. అది ఎగ్జామ్లో రాసేటప్పుడు మాత్రం రాసుకోండి సరిపోతుంది. టైప్ 2 నాట్ ఇన్ ద ఫార్మ్ ఆఫ్ టైప్ 2. దెన్ వీ హ్యావ్ టు చెక్ అబౌట్ టైప్ 2 కూడా ఫెయిల్ అయిపోయింది. ఐ మీన్ చేయలేము, అప్లై చేయలేము. టైప్ 3 ఆ టైప్ 4 చేయాలి. టైప్ 3 నా టైప్ 4 చేయడానికి వాట్ ఐ డిస్కస్డ్ ఎర్లియర్, ఐ మెన్షన్ యాస్ ఫైండ్ అవుట్ dou m by dou y minus dou n by dou x value. Dou m by dou y minus dou n by dou x value. Okay, so finding that dou m by dou y and dou n by dou x, it's a very important step. So writing in red color, dou m by dou y minus dou n by dou x. Dou m by dou y is minus 2y minus dou n by dou x is plus 2y. If we do these two things, what we will get? Minus 4y. So we are getting how many number of terms here? We are getting dou m by dou y minus dou n by dou x is getting only one term, but it is in functions of x or y. That is not important for us. Which one is important? This one we have to multiply with which one? Dou m by dou y and dou n by dou x we have to multiply with 1 by n or minus 1 by n. That is important. So with which one we have to multiply? Again, I am going to take here highlighter. Okay, this is we got dou m by dou y minus dou n by dou x value. How many terms we have? Only one term. But when it comes to m, how many terms are there in m? 3 terms are there. So
3.
is there any possibility that అసలు జనరల్గా ఆలోచిస్తే కూడా we cannot cancel the one term with these 3 terms. So check n contains only one term, so there may be a possibility that we can cancel dou m by dou y minus dou n by dou x with the combination of 1 by n, with the combination of 1 by n. So please remember 1 by n is equals to 2xy. So I am writing now direct step here. So I am
1 by
I am taking here 1 by n into, better
dou m 1 by dou m.
1 by n into
Dou
dou
m by
y
dou y
minus
minus dou n by dou x.
dou n by dou x. If I take like this, 1 by n value is 2xy.
Yes, sir.
2xy into dou m by dou minus dou n by dou x is minus 4y. If we observe this, if we do cancellation, then we are going to get here, it will be minus 2 by
2
x. Now check according to our discussion, 1 by n into dou m by dou y minus dou n by dou x only in functions of x variable. Are we getting only in functions of x variable or not? So taking this as f of x, it means it should be only in functions of x or constant, but it should not contain any y variable. Say if I am taking this as f of x, then what is the integrating factor? I of equals to e power integral f of x into dx.
f of x dx.
F of x into dx. So f of x value e power integral minus 2 by x into dx. So minus 2 is constant, bringing outside of the integration, minus 2 into integration of 1 by x into dx. Integration of 1 by x into dx is log x. Okay, it is in the form of n log a, exponential of log a power n. What is a? X power n is equals to minus 2. So we'll get here, it is equals to x power minus 2, nothing but I can write it, this is as 1 by x square. This is integrating factor. So now we got the integrating factor 1 by x square. Why we are finding this integrating factor? For converting this non-exact differential equation to exact DE. So we identified this is non-exact differential equation here, and we have to convert this non-exact to exact, so that we identified the integrating factor, multiply equation number 1 with if on both sides, then it converts to a differential equation. As usual, I'm not discussing from here. I'll just discuss orally. You do it the problem, complete this problem later. So the reduced equation, we have to take it as equation number 2, and we have to take it as compare with m1 dx plus n1 dy equals to 0. Check whether m1 dx plus n1 dy equals to 0 is an exact అవుతుందా లేదా అనేది చెక్ చేయండి. ఎగ్జాక్ట్ అవుతుంది గ్యారంటీగా. If it is exact, then you know how to find its general solution. So fine, this is the concept of exact and non-exact. And ఇంకొక టైప్ ఉంది, ఆ టైప్ మరి till now in type 1, type 2, type 3, type 4, we are finding integrating factor if the given differential equation is non-exact, if it is homogeneous type 1, if it is not homogeneous type 2, and it should be in the form of some type 2 case. If it is not in the type 2 case also, then we have to go for 1 by n into dou m by dou m minus dou n by dou x. It should be only in functions of x variable. That's a type 3. Integrating factor is e power integral f of x into dx. Then if it is not satisfying, then we have to go for type 4, minus 1 by m into dou m by dou m minus dou n by dou x is equals to function only in functions of okay, that is only in functions of y variable, then type 4. So like this, we are having some certain conditions to take integrating factor. But here in the type 5, we are not checking whether a given differential equation is exact or non-exact, and we are not checking any conditions. Homogeneous type 2 లో ఉందా, లేకపోతే 1 by n into dou m by dou m minus dou n by dou x లో ఉందా, లేకపోతే ఇంకొక కేసులో ఉందా అనేది మనం ఏమీ చెక్ చేయం. ప్రాబ్లం చూస్తూనే by seeing the problem, we have to identify it is in the form of type 5, and we can guess ఇంటిగ్రేటింగ్ ఫ్యాక్టర్. ఇంటిగ్రేటింగ్ ఫ్యాక్టర్ ఫైండ్ అవుట్ చేయడానికి లీనియర్ డిఫరెన్షియల్ ఈక్వేషన్స్ ఆఫ్ ఫస్ట్ ఆర్డర్ ఫస్ట్ డిగ్రీ ఏదో చేసాము, బెర్నౌలీలో ఏదో చేసాము, అండ్ ప్రీవియస్ ఎగ్జాక్ట్ నాన్ ఎగ్జాక్ట్లో 4 టైప్స్లో ఏదో చేసాము. కానీ ఇక్కడ ప్రాబ్లం చూస్తూనే మనం ఇంటిగ్రేటింగ్ ఫ్యాక్టర్ ఐడెంటిఫై చేయొచ్చు. సో ఇంటిగ్రేటింగ్ ఫ్యాక్టర్ ఐడెంటిఫై చేసేస్తాం, డైరెక్ట్గా మల్టిప్లై చేసేసి అప్లయింగ్ ఇంటిగ్రేషన్ ఆన్ బోత్ సైడ్స్. సింపుల్ మెథడ్ అండ్ ఈజీ మెథడ్, బట్ ఓన్లీ థింగ్ ఈస్ we have to identify that the given problem is in the form of type 5. So for learning this type 5, I am going to give you few columns, group of terms. In the given problem, it must have some group of terms. What are that group of terms? That group of terms I am going to give you here. That group of terms, and if the group of terms are something, then we have to identify some integrating factor and then formula. I'm mentioning it is as formula, but it is not formula. It is final stage. So now what is that? So what are the group of terms? And depends on the group of terms, what is the integrating factor we have to identify, and from that what we are going to get the formula. So here I am mentioning with different things. Okay, x dy plus y dx. If the given group of terms are like this, then we can take the integrating factor is 1 x into dy plus y dx. We can write like this. If we observe, what is the differentiation of UV formula? What is the differentiation of UV formula? UV dash plus VU dash. UV dash plus VU dash. Okay, so we can write it is as d of xy. So u into v dash, that is nothing but x into dy, plus v into u dash, that is y into dx. It's already like that. So d of xy equals to x dy plus y dx. దీన్ని దేంతో మల్టిప్లై చేశాము? 1తోనే మల్టిప్లై చేశాము, అందుకే ఇట్లా ఉంటుంది. ఓకే, నౌ గోయింగ్ టు టేక్ ద సెకండ్ వన్, x dx plus y dy. X dx plus y dy. So I am multiplying with the 2. Even if I am not multiplying with 2, then we'll get 2 only. So I am writing the formula first and then the expression. నేను వచ్చేసి I am going to write a formula here, d of x square plus y square. Finally, the final step from this, I am going to write it is as product of group of terms and integrating factor. That I am going to do. So now tell me, what is the differentiation of x square plus y square? 2x dx plus 2y dy. Okay, from these two terms, can I take 2 common? If I take 2 common, 2 into x dx plus y dy. Now if we observe, then what can we identify? Multiply the group of terms and integrating factor, then are we getting this one only? So wherever we have this 2 into x dx plus y dy, I am going to write from here onwards d of x square plus y square. D of x square plus y square. Next one is group of terms is important. Next group of terms. So better I'll increase the okay. Now the group of terms, what's the differentiation of u by v? What's the differentiation of u by v? Same manner, what's the differentiation of u by v? Vu dash y dx minus x dy. Minus x dy. These are the group of terms I am taking. In this case, integrating factor will be 1 by y square. I'll tell you what is that. What is the differentiation of x by y? What's the differentiation of u by v? V into u dash. Nothing but what we'll get here? Y into dx minus uv dash x into dy. Are you understanding? Are you able to understand this?
No.
Okay, right. Now check here. The numerator part is our group of terms y dx minus x dy, and 1 by y square is our integrating factor. So if we are able to write like this, then we can get this same group of terms. I am taking y dx minus x dy, but I am taking the integrating factor as 1 by x square. When we have to choose 1 by y square and when we have to choose 1 by x square, that I will tell you after completion of all the formulas. Okay, so whenever denominator contains, that means integrating factor, if we are taking y square, then the formula is d of x by y. When I am taking x square, this x should be in the denominator. So we are going to get the formula of d of y by x.
Y by
D
X.
of y by x. So differentiation of y by x is equals to, as usual, x into dy minus y dx
My Y
by x
by
square
X square.
x square. So can I take minus 1 by x square common? If I'm taking minus 1 by x square common, that means minus 1 common from numerator, then we are going to get y dx minus x dy minus x dy, y dx minus x dy. Now check y dx minus x dy is are the group of terms, and 1 by x square. But we got minus 1 by x square. సరే మనకి మైనస్ ఇక్కడ వస్తుంది అంతే, డిఫరెన్స్ ఏం లేదు, మనం ఏం వరి అవ్వాల్సిన అవసరం లేదు. Okay, so these are separate case, and same manner, same group of terms I am taking y dx minus x dy. If I take y dx minus x dy, then the group integrating factor may be 1 by xy, 1 by xy. In this case we are going to get differentiation of d of log of x by y, log of x by y. So what is the differentiation of log function? Differentiation of log x is 1 by x.
Okay.
In place of x we have x by y, 1 by x by y into d of x by y, d of x by y. Now again reciprocal of x by y is y by x, and differentiation of x by y is y dx minus x dy minus x dy by y square, y square. If we do simplification here, if we do simplification here, then what we are going to get, so this y gets cancels with the square, then we are going to get 1 by xy into y dx minus x dy minus x dy. This is the thing. And one more integrating factor I'm going to give you for the same group of terms, same group of terms. So y dx minus x dy, the group integrating factor is 1 by x square plus y square. Whenever we are going to take this is a 1 by x square plus y square, the formula will becomes like this: differentiation of tan inverse of sorry, not t inverse, it is tan inverse, tan inverse of x by y is equals to, what is the differentiation of tan inverse x? What is the differentiation of tan inverse x? 1 by 1 plus x square, 1 by 1 plus x square. Here x is equals to how much? X by y. So we can write this as 1 by 1 plus x by y whole square into, but x by y is not exactly in function of x directly, only x అయితే మనం x square పెట్టేస్తాం, but it is in functions of x, so we have to write d of x by y. So now if we do simplification in the denominator, LCM in the denominator is y square, and the in the denominator numerator part is y square plus x square, and what is the differentiation of x by y? Y dx minus x dy minus x dy by y square. Now if we do reciprocal, if we do reciprocal, then what we are going to get here, the first term 1 by x square plus y square by y square becomes as y square by x square plus y square, ante kada. So I'm going, this is going to the numerator part, but when it comes to the numerator, this numerator and this denominator gets cancelled, so I am writing direct step 1 by x square plus y square into x square plus y square into y dx minus x dy. So now check our group of terms and our integrating factor multiplied here or not. So these are the few formulas which we are going to use. Anyhow, I'll give some gap whenever it requires. I'll explain that formulas also. So before I am going to start problems, I am going to give you a different type of group of terms also. The different type of group of terms are, instead of y dx minus x dy, if I am getting x dy minus y dx, what we are going to get? Can I take minus common from this? If I take minus 1 common, then are we going to get our previous equation? This one, this group of terms వస్తాయి కదా, -1 కామన్ తీస్తే. సో అలా అన్నా చేయొచ్చు, లేదా okay, you can do it like that, no problem at all. So I'm not discussing problems on this. Otherwise, one thing I'll explain. So if I'm multiplying with 1 by x square, then what we are going to get? So differentiation of y by x తీసుకోవాలి. ఎందుకు తీసుకోవాలని చూద్దాం. Differentiation of y by x equals to x into dy minus y dx by x square. Now check it. 1 by x square is the integrating factor. X dy minus y dx is the group of terms. X dy minus y dx are the group of terms. So this is the thing. Now how to identify? In this case, we discussed a few formulas with the writing differentiation of x by y, differentiation of y by x, or differentiation of log of x by y, or differentiation of tan inverse of x by y గా రాసాము, differentiation of y by x గా రాసాము. ఎప్పుడు x by y రాయాలి, ఎప్పుడు y by x రాయాలి? When we have to write x by y and or when we have to write y by x, that is important point here. When we have to write, okay, now you observe here, what is the first term? Contains x. Whenever x is there, this x should be in denominator. Okay, the y is there, this y is in denominator. Going up, now check, y is there, this y should be in denominator. సరే, ఈ దీనికి వదిలేసే, దీనికి వద్దు, ఏం చేయాలో చూద్దాం. సరే, ఫస్ట్ దానికి చూద్దాం. y ఉంది ఇక్కడ, y డినామినేటర్లో ఉంది. సో ఎప్పుడైతే మనకి y dx వస్తుందో, whenever we get like y dx, that y should be in the denominator of inside the differentiation. That's the point you have to remember. And then we are having y here also, but y we are not taking here. It is y in denominator. If you multiply this with this 1 by x square, then it goes to x dy minus y dx by x square. So ఇందులో నుంచి -1 కామన్ తీస్తున్నాం కాబట్టి అక్కడ మనకి సరే, ఇందులో నుంచి -1 కామన్ తీస్తే ఏమొస్తుంది? ఎక్సే వస్తుంది కదా. అందుకోసం ఇక్కడ x వచ్చింది కదా, x వచ్చింది కాబట్టి then we are taking x in the denominator. So these are the finding integrating factors directly by seeing the problem. How to understand? By seeing the problem, which integrating factor we have to take. That is important. I'm going to discuss now. Okay, one second. Okay, now I'm going to take a problem. So better I'm giving some gap for doing, for writing any formulas if available. Okay, so now taking a problem, here it is. Same manner here also they will mention as a solve. Here I am taking y dx minus x dy plus 3x square y square into exponential of x cube into dx equals to 0. Okay, so this is the problem they given to us. How to identify whether it is exact or non-exact? Don't get confusion. It's a very simple process. We are not going to check whether it is exact or non-exact. Why? The reason is, if you observe y dx minus x dy, how it looks like? It is a group of terms like this.
y
dx minus x dy. Whenever y dx minus x dy, what are the integrating factors we can take? 1 by y square, 1 by x square, 1 by xy, 1 by x square plus y square. Anything we can take, but it is not possible to take all at a time. ఈ 4 కేసెస్లో from these 4 cases, we cannot take all the 4 cases. Only one case is possible. What is that one case? That is important for us. For identifying the integrating factor for this group of terms, we have to concentrate on the non-group of terms. ఈ గ్రూప్ ఆఫ్ టర్మ్స్ కాకుండా ఇంకే టర్మ్స్ ఉన్నాయి, ఇంకొక టర్మ్ ఉంది. ఆ టర్మ్ని బేస్ చేసుకొని మనం ఆ ఇంటిగ్రేటింగ్ ఫ్యాక్టర్ ఏంటి అనేది ఐడెంటిఫై చేస్తాము. ఎలా ఐడెంటిఫై చేస్తాము అంటే, సో ఐఎమ్ అరైజింగ్ దిస్ నౌ. వీ హ్యావ్ టు కాన్సన్ట్రేట్ ఆన్ దిస్ సెకండ్ టర్మ్ ఓన్లీ. ఇన్ దిస్ సెకండ్ టర్మ్, try to observe what we have here. Dx we have. Whenever dx is there, the coefficient of dx must be only in functions of x variables. Only in functions of x variables. So other than x variables, anything else which is in terms of y variable, please identify that. What is that? Y square is there. So this y square is there. This we have to eliminate. For eliminating y square, I'm going to divide with, one second. So we are dividing with y square on both sides, then it will become y dx minus x dy by y square plus 3x square e power x cube into dx equals to 0. So if we observe the first term, the first brackets can be written as differentiation of x by y using our formulas, plus actually what is the integrating factor here indirectly? That is integrating factor if equals to, what is that? 1 by y square. With 1 by y square only we multiplied on both sides. Okay, anyhow, we are not going to write like this, but this will be useful for object type questions. They'll give the same problem. They will ask us to find what is the integrating factor for this problem for 2 marks or 3 marks. It depends upon the your pattern. Okay, so I'm writing the second term as 3x square into e power x cube into dx equals to 0. Now I'm applying integration on both sides. Why should we have to apply integration on both sides? By using the variable separable method, that is the basic concept of solutions of ODE, first order first degree ODE. Dx coefficient only in functions of x variable. D of x by y, we have to treat x by y as a variable. You treat as z. So dz coefficient is only in functions of z. That means nothing is there. So we have to treat it as a function only in terms of z. So apply integration on both sides. Apply using variable separable method. Apply integration on both sides. If I apply integration on both sides, then we will get integration of d of x by y plus integration of 3x square exponential of x cube into dx equals to integration of 0. So if you observe what we discussed earlier, we know that integration and differentiation both are inverse operators. So we'll get the first term value is x by y directly, plus integration of, we cannot find this integration, we have to apply here integration by parts. Or we can apply here one more special case, that it is substitution method. I'm going to substitute what we have to substitute here. Inside the exponential, what we have? X cube. In exponential we have x cube, so put x cube is equals to a new variable. Taking it as t. We can substitute with any variable, but that variable should not repeated earlier in this same problem. In this problem till now we discussed only x and y variables. So differentiate on both sides, we'll get 3x square into dx equals to dt. Now if we observe 3x square into dx, we can replace with dt. So e power x cube is nothing but t, 3x square into dx is nothing but dt is equals to integration of 0. Then on x by y plus integration of e power t with respect to t is e power t only is equals to c. Is the solution is completed, integration is there is no integration term at all, so I am going to add the integration constant which is plus c, but replace t. What is the t value? T is equals to x cube. If we replace t equals to x cube, then we are going to get x by y plus e power x cube is equals to c. Is the general solution of given differential equation. We didn't check whether it is exact or non-exact. Even it is exact or non-exact, this process is a simple process which is type 5. Is general solution of given dA. So like this, we can do problems on this, but for the name's sake, what is the integrating factor? For identifying the integrating factor, I am going to discuss few more problems, but not full solution. I'm not going to discuss full solution. I'm just going to discuss up to some extent of the problems. So the problems are, here it is like this. X dy minus y dx is equals to xy square into dx. Now tell me, what are the group of terms we have here? X dy minus y dx we have. X dy minus y dx we have. To this x dy minus y dx, these are the group of terms. What are the non-group of terms? This one.
X into y square.
X into y square into dy. From this, what can we understand? Dx is there. Dx coefficient must be only in functions of x variable, but not in terms of y. So what we have to do here, divide with, otherwise multiply with 1 by y square on both sides. If we multiply with 1 by y square, it's going to become x dy minus y dx by y square is equals to x into dx. But we are not able to write LHS part in the form of any formula. What is the differentiation of y by x? ఇక్కడ నేనేం చెప్పా, x ఉంది, x ఉన్నప్పుడు ఏం చేయాలి, p of x by y. What is the differentiation of x by y? x dy minus y dx by x square. కానీ ఇక్కడ y square ఉంది, అప్పుడు ఏం చేయాలి మనం ఇక్కడ? What I am going to do is, I am taking minus 1 common. If I take minus 1 common, y dx minus x dy by y square. Now check LHS part, it looks like our format. So we can write it as minus 1 into d of x by y is equals to x into dx. Okay, so we can apply integration on both sides because LHS part contains only x by y terms, right? RHS part contains only x terms. So apply integrations. So we will get, what is the solution? I'm not writing any step, but simply writing the integration, integral minus 1 into d of y by x by y is equals to integration of x into dx. So we'll get here minus of differentiation integrating x cancel, we'll get x by y is equals to integral x dx is x square by 2 plus c. This is the general solution of given differential equation. So, but if you observe, this is the mdx plus ndy form. If you compare with mdx plus ndy, check it. You may get exact or non-exact. Okay, if you get exact, in 2 to 3 steps you can get the solution. But if it is non-exact, you have to identify whether it is homogeneous or non-homogeneous. Sorry, not a homogeneous DE. No, it is in the form of type 2 or type 3 or type 4. That everything is we have to identifying integrating factor. That everything is a lengthy process. This process is easy only if the group of terms we can identify. This group of terms must be existed in our list of what you call our cases. మన ఫార్ములాస్ లో ఉండాలి. సరే, ఇంకొక ప్రాబ్లం చెప్పేసి విత్ దిస్ ఐఎమ్ గోయింగ్ టు స్టాప్ దిస్. ఓకే, ఐఎమ్ గోయింగ్ టు టేక్ ద థర్డ్ వన్ ఈస్
అంటే ఈ 2 మార్క్స్ వస్తాయా?
2 మార్క్స్కి వస్తాయి, 5 మార్క్స్ కూడా వచ్చే ఛాన్స్ ఉంది. ఎందుకంటే
5 మార్క్స్ ఎలా అడుగుతాడని
సింపుల్ గా సాల్వ్ అని అడుగుతారు. Simply they will ask us to solve, that's enough. They will not ask మనకు తెలియదు కదా ఇది చిన్న ప్రాబ్లమా పెద్ద ప్రాబ్లమా అనేది. So okay, if we have a problem like this, then what to do? What are the group of terms? ydx minus x, ydx minus x dy. So what is the non-group of terms? This one, non-group of terms is with pink color. So dx coefficient ఎలా ఉండాలి? x లోనే ఉండాలి. y లలో ఉండొచ్చా? ఉండకూడదు. dx coefficient must be only in terms of x, but it should not be in terms of y. So we have to eliminate y from this. Can we eliminate y? No. చేయలేము. ఎందుకు? x square plus y square is there, so that we cannot eliminate only y square. So that purpose I'm going to multiply on both sides with 1 by x square plus y square on both sides. 1 by x square plus y square on both sides. Then we will get y dx minus x dy by x square plus y square is equals to a dx. Okay, how can we write LHS part? Differentiation of, how we can write? Whenever x square plus y square in denominator, then we can write it is as tan inverse of x by y. Check the list of formulas. The last formula we discussed is equals to a into dx. So apply integration on both sides, because already it is in the form of variable separable. Apply integration on both sides, then we'll get integration of differentiation of tan inverse of x by y is equals to a into integration of dx. So if we do integration, then integration and differentiation gets cancelled. We'll get only left hand side part is tan inverse of x by y. Tan inverse of x by y is equals to a into integration of dx is x, completed integration, so plus c. This is the general solution. It's completed. అదే వెనెవర్ ఇట్ ఈస్ ఎగ్జాక్ట్ ఆర్ నాన్ ఎగ్జాక్ట్ చెక్ చేయాలి అంటే ఫస్ట్ ఎండిఎక్స్ ప్లస్ ఎన్డివైగా తీసుకోవాలి. ఎండిఎక్స్ ప్లస్ ఎన్డివై తీసుకోవాలంటే ఆర్హెచ్ఎస్ పార్ట్ని కూడా లెఫ్ట్ హ్యాండ్ సైడ్కి తీసుకుపోవాలి. We have to take RHS part or to LHS part. Then dx coefficient become y minus of a into x square plus y square. అది m అవుతుంది. n వచ్చేసి మైనస్ ఎక్స్ అవుతుంది dy కోఫిషియంట్. సో ఇవి రెండు ఈక్వల్ అవ్వవు, ఏవి ఎగ్జాక్ట్ అవ్వదు. ఎగ్జాక్ట్ అవ్వనప్పుడు నాన్ ఎగ్జాక్ట్ అవుతుంది. నాన్ ఎగ్జాక్ట్ అవుతుంది కాబట్టి ఇది టైప్ 1 ఉందా, టైప్ 2 ఉందా? టైప్ 1లో ఉండదు, టైప్ 2లోనూ ఉండదు, టైప్ 3, 4లలో కూడా ఉంటుందో లేదో చెప్పలేము. సో అటువంటి కేసులో ఇంకా వేరే ఆప్షన్ ఏమీ ఉండదు. దిస్ ఈజ్ ఓన్లీ మెథడ్ వీ కెన్ ఫైండ్ ఇట్స్ సొల్యూషన్. ఓకే, సో దిస్ ఈజ్ ఎండ్ ఆఫ్ solutions of first order, first degree ordinary differential equation with the exact or non-exact types.